Продолжит тему производительности Андрей Зубков.
Let's start. The efficiency subject will be continued by Mr. Andrey Zubkov. Hello everyone, my name is Andrey Zubkov. I am administrator of the databases and I came to Postgres from Oracle, and of course I needed tools for analysis of the performance. And I decided to create such a thing in Postgres. Good question is, who is familiar with this thing? Who likes it? Who hates it? PG profile. Not so many people. Okay, so it means that this presentation will make even more sense. So why do we need this tool? One of the main tasks for the database administrator is when developers come to you and tell you that the database is slow, that the application doesn't work. And of course, they will first go to the database administrator. And of course, we need to have a possibility to be able to look in the past to understand, for example, what was slow during the night when administrators were sleeping. We need to understand what happened in the database at the time, and we need to look for queries which loaded the database the most, and we need information about the scalability, the tables, the indexes of the database, and the new functions, which are quite new for profile, is the comparison between the loads and the profile during the different time. So we can compare what happened in comparison with yesterday, for example. When we investigate incidents, of course, for example, when there is a release update, we need to understand what changed in the characteristics of the load on the database. This is a high caliber canon which allows us to understand what happened. Of course, it will not give you the exact reason, but with a high probability it will show you where to look. And analysis of the results of the load tests. For example, we need to start load test in the database, and we would like to look how this load test reflected, and to measure how many transactions has been done, how many updates of the tables, and how much time has been spent. The classical example for the monitoring system, it will show you the graphs, the metrics. The graph is old, but the sense is the same. The meaning is the same. Some metric where we observe a big fluctuation. For example, in this case, it's hard drive space in the database partition. I will not stop on this case in detail, but I will just refer to it, which it happened 2 years ago, related to some temporary files. What do we need? We need a repository for storage of the historical data, where we will store what happened in the database some time ago. And we should do it in a way that it will not use too much space. And the report with the objective values of the metrics, as a result, we would like to collect the report for a certain period of time and to look what happened, and we would like to see the exact values to be able to compare it with something. We would like to affect our database as minimum as possible, so we will not observe any problems with the productivity. DBA would like to be able to install it as simply as possible and to avoid the monitoring. And in addition to that, optimization of the performance. The most interesting for us is the most loaded objects and the most loaded queries. This will enable us to save space in the repository of the historical data. We will not take the objects with small number of changes and with small number of queries. which doesn't create much load, we will save some space. What's available about this? POWA, for example, it's a nice tool with nice pictures. It's based on statements, PGStat statements, and it has web UI, which is installed not so simply. Then PGClue, also useful tool which is able to build some graphs and reports and metrics, but it works in a way that when we start it, it collects the statistics from the database, and then we can create a report to understand what happened. And this is as a permanent tool for constant monitoring in the database. And when we take a certain period of time for report, it can collect only the data for a certain interval or period when the statistics was gathered. And if we're trying to glue them together, PGClue cannot do it this way. PGBadger, it analyzes the logs, and it's clear why. Postgres puts in logs, writes in logs much more than it's possible to extract from the dynamic tools. So this is a good tool, but it requires logging, because if we have lots of queries, then each one of them separately will not be able to work too fast. And we will have to write everything in the log, and we need subsystem of logging of the according efficiency, because also analysis of such logs will take a lot of time. And this tool also is not suitable for all cases, and profile is mostly relevant to the class of tools of statements. The idea is to, we have time during which we take the images or screenshots. PG profile works with cumulative statistics, which increase constantly. And this is a classic example of database where the metrics are increasing over time, and it's very suitable in this manner, because we're not doing too much images and screenshots, and we do not load the database too much. We can take screenshots maybe once in half an hour, once an hour, and it should be enough to initiate the processes which load the systems too much. For example, if some query loaded our server for 1 or 2 minutes, with high probability we will see it. So we take screenshots, and each screenshot will show us, for example, block reads 20, snapshot 2 shows us 40. So in this way we will get delta, and other metrics are similar, and then, for example, we will see the data in the snapshot, and when we will collect the report for 3 hours, for half a day, then we will just combine this data from each snapshot, and we will get a certain result in the end. Architecture. This is an extension written on clean PGSQL, and it doesn't need anything in addition to Postgres to work in the system. Just for screenshots, you will need something similar to Chrono, but almost every operation system contains it, so it's quite a standard tool. You can use cron in Postgres Pro, for example, or scheduler. And in normal Postgres or Linux, you can take cron and you can go ahead. It will take screenshots. Repository of storage of screenshots. Mechanism of collection of data for snapshots. There's a different snapshot functions. There are various of them, but you can use basically just one, and then they will call each other, and they will collect the statistics data from wherever they can. And then build up of the reports. It's a separate function which is called reports. There are several such functions, and they enable you to collect a report from several snapshots. Each snapshot has a time when it was taken, and we know the duration of time to understand what happened in the database. And then we identify two snapshots, for example, for this function, and then it will create a report in HTML. It's basically a text which can be transferred to some file and then put into a browser. So, where the PG profile takes the data from? First of all, PGStat statements, of course, but with some comments, which I will tell you later. Other Postgres tables and indexes, PGStat user tables, will show you statistics about what happened. Stat.io, in case if track.io is switched on. This is statistics of tables and indexes. Stat user functions, this is statistics of user functions calling. PGStat database, everybody knows what it is, and PGStat BG writer is statistics of checkpoints, background writers, and also what happened with backend, I mean dumping of blocks. Maybe 1 year ago, PG profile added the possibility to combine several clusters. Why do I need this? I had a situation when we had to collect statistics from read-only replicas. As PG profile was writing data in the same database where it was installed, and on standby it's impossible to write it, and such thing was created, and PG profile could be installed on one machine and to take statistics from different clusters of the database. And it's not necessarily can be read-only replics, but if you need a read-only replica, you can connect it as well. Node cluster of Postgres shows you the name, the connection string, and if it's enabled or not. Drop, delete of node, enable, disable connection string if you need to change. And node show to see the nodes which are connected. Enabled node are the nodes which are connected during the snapshot function, which takes statistics from all of them. If it's enabled, then it will take it from them. If it's disabled, then it will skip them, and you can take it with snapshot, but with indication of the node. So how it happens? This is a scheme which shows you two clusters, PG profile cluster and node cluster, but in fact it can be only one cluster, of course, but in any case it will happen in the same way. There are node clusters, which can be several. There is a shadow, which means that there are several instances. PG profiling cluster, where it's installed, will open the main DB link in accordance with connection string, and they will extract whatever can be extracted from the cluster-wide statistics from PGStat database and PGStat statements, and later, depending on the number of databases which were found in the cluster, for each database it will connect with a separate DB link to collect the statistics based on the tables, on the indexes and relations, because otherwise there is no other way to collect them. And then it performs PGStat statements reset, which is an important thing, because PGStat statements is great, but with one exception. It can end and it extract from itself the queries which are too old and which do not fit any longer. And if we take some data from PGStat statements and then we take another screenshot, and we will not have a way to understand if some queries went out of stat statements, some new ones came, and we do not have any data if the data is correct or not. So between the two snapshots from PGStat statements, one query can be removed 3 times and come back 3 times. And the statistics which are in there currently can be not up to date. So we perform the PGStat statements reset, and PG profile looks when we take the next snapshot, it looks if 90% of PGStat statement max, if we have more than 90% statements, then it releases a warning that maybe not all of the queries were cached. And the PGStat statements is not the only one, but important. And we have to reset it. There is no other way to guarantee that we have an up-to-date data. This is a sample of snapshot with Chronos statements. It does the snapshot every 30 minutes. It's better to install it in the scheme, but I will tell about it later. Baselines. I don't know how to call it in Russian, but basically this is an Oracle term. Baseline is necessary to remove certain snapshots from the standard storage policy, because otherwise the repository will become too big if we will not delete anything from it. And from time to time we need to delete something, and there is a parameter which is in charge of removing all the data from repository. A few things need still to be developed, but in a simple case, it's good enough, it's correct enough. Baseline new creates baseline. This is not a mandatory parameter, and it will be created for the local node, which will be created automatically in case of installation of extension. And it's not mandatory if you're performing this command on the same cluster. You monitor it and you put it by default, and you do not need to remember about the node. You just dump it anywhere you want, and you do not need to remember it, you do not need to write connection strings. Most probably it will be good enough as it is. Then you indicate the identifiers for snapshots and the number of days of storage if you want to overwrite the standard. Then it will become infinite retention, so it means that it will store it infinitely and it will not delete anything. Then you can drop the baseline, putting the name, and you can change the time of storage to put it explicitly. And also you can show the baseline from node or locally for this node. Then creation of reports. First of all, we would like to understand which snapshots we have, and of course it leaves much to be desired in a way that it's Oracle approach working here. It takes the identifiers of the same snapshots. But this is not convenient, and when I was writing this, when I started to write it, I created it in a similar way, and then I stopped. But then we should use maybe date time, not to jump with snapshots with unnecessary movements. But it's in the future. At the moment, we have a list of snapshots and the time when they were taken. We can take it from snapshots table, it will be similarly complex. We can put the number of days into the past, how far in the past we would like to look. If we have a long retention and we save snapshots for a long time, then snapshot show will be quite long, and we can put one, it will show maybe the snapshots for the last 1 day. Then creation of reports, it's a simple calling of PSQL where we call the report function and we indicate two identifiers of the snapshots between which we're interested in interval during which we can build the report. And option O, we can send it to HTML file or we can also send it somewhere else. We have two options. We can put identification or baseline name. In the future, maybe date and time will be also available, but baseline, in addition to collection of reports, it's also convenient for golden baseline, which we would like to look regularly. It's a good option. HTML we get in the end, and we can put it in any browser and review it there. It's quite simple CSS and in this report. Soon we will look at the report, the sections of the report. Cluster statistics, this is cluster right within the scale of the whole cluster with the database, with the statements. There is aggregated statistics for all statements which are collected in PG start statements between the snapshots which we're interested in, and the cluster stats which are referring to BG writer, checkpointer, and other things in the third table of cluster stats. SQL query stats, it's what we take from PG stat statements, sorted in a different way, by elapsed time, by execution, by IO wait time, also by read blocks from the pages, by temp, so anything you can take from stat statements. Complete list of SQL tests I will show you later.
So the schema object stats, that's where we get everything what we have collected based on the objects of the base data on the tables, on the indexes, how many we have sorted by DMLs, by deleted, by updates, I mean in terms of vacuum. The growing tables, the growing indices, and the unused indices. This is very inaccurate thing because it only tell you that you have the indices on the tables under which certain changes are taking place, but these indices were not scanned. But this only shows it for the interval that you are collecting the report from. So it does not mean that you can delete this index. But if you understand what you're doing, then to have a look at what exactly happened over a certain period of time in the indices, and the schema of object stats is the objects that have been collected over the time, but it's not collected all the time. It's only collected if you have the parameters switched on. User function stats, well, you understand what it is. It is the statistics on the function. This data is collected by Postgres, and here they are sorted with accordance to the time that is required for these functions, but cumulative time, and according to how often were these various functions executed. Vacuum-related stats is some sort of black magic here because it is different from all the other tables of reports because it is only current for the latest version of the snapshot that you have been doing by the very end of your report. So it does not give you an understanding of a period of time. It only shows you the very last moment. It shows that at the last moment of the snapshot you had like this or this tuples and modified tuples, and one is concerning the vacuum, the other one the analyzer. Now, so to not go into useless details, an easy example. We load PG Bench, is a couple of seconds, 10 clients, the easiest one, and we look at the report. Now, if we are lucky, we will be able to see where? No, we will not be able to see. Okay, we'll just do it like that. Okay. And this is an example of a report. Now it looks, what is this? Okay. Now all these are links. They're very easy to use to navigate. This is a long sheet paper, and here you can have the database stats. Now what happened here? Here I think it's applicable to switch back to the presentation. Now where is it? Okay, there it is. No, not this presentation. Yes, this one. And here we can see that we had 71,000 and something transactions here, and we can see them that here there are slightly more, and this is understandable because the report was gathered a little bit beforehand and a little bit after, and the PG bench did that. So I understand that there were more transactions that happened in the database during this period of time, and this is for the statement on the aggregated statistics on PG statements, how many you had inquiries happen in PG Bench and Postgres, and there were a number of other databases which I had in this cluster. Now there was no life. We just counted ourselves how much the profile counted in, and of course the overall statistics, the grand total, is how many different statements you had. And all this can be taken from the PG stats. It's an aggregator. And now, how many you had checkpoints which were scheduled, which were requested, and so on and so forth, and how much time it took to write, to synchronize, and so on and so forth. And PG writer, whatever else it has. And cluster-wise statistics on how much val went through and was accumulated over this time. Now, after this, we see the requests, SQL, QL stats. According to the elapsed time, they're sorted and they're all here. You can have a look at who's the leader, and you can straight away give out the boons. Now, of course, this is the PG bench and the update, and according to this, you can see what the PG bench did. And here already we are seeing no miracles. We have this amount of executions. It's in full correlation. And here in the transaction, you see as many as it is necessary, and we know how much time each request takes. And I'm going to come back to this field later, because it does not always show correct things. It all depends on your settings. And later, everything is fairly clear. Everything is like in PG stat statements. You have the minimal time, the maximum time, the standard main error, and how much of cumulative statements it had for all the 71,762 iterations. And it may seem weird, but it brings it back on every iteration. Now this is as far as elapsed time is concerned. Now next we have executions, and we're going to see what commands are executed the most, queries are executed the most frequently. It's very useful if you're trying to find out some strange cycles that are constantly executing the same query over and over again. Even though it's not creating any extra load, there is no point to it. And the IO wait time, it didn't catch anything. It seems that everything was in the buffer zones, so we did not go onto the disk. Now the SQL it shows us how many pages were read, and we once again have a percent total, how much was caught by it into the caches, and how much executions we have, and so on and so forth. Everything is fairly clear. Then we have the temp usage. We had no temp there, which is why we have no idea what has been going on with it. And then we have a long sheet with all the queries, and in our case it's short, and there are not very short queries, but there could be a case where you have long and interesting ones. Next is the statistics on the objects in the schema. Here is much more interesting than the PG stat statement, so because here we do not have any weird settings that it depends on. Here we just look at what happened, why it happened, and here we have objective statistics, even in the cases where PG stat statements will not help us. And I'm going to talk about this later, but it's going to be an objective statistics that is going to help us obtain at least something within the absence of PG stat statements, to at least look at what tables something foul is taking place. Then you have the DML tables. And this is the sorting by the DL tables and deletes together. It's sum, and then you have the sequential segs and index scans. Here they're also part of this, just for reference. and then delete update of our account, just so that we understand how much DML operations took place that require a vacuum to be run, and we can assess how many times vacuum went in there. If we had larger intervals and more changes in the database, then we also had more vacuums here. And yeah, not funny. And then growing tables, because the example is dead-born, so nothing is really growing here, but yeah, well, maybe slight growth. But if we were to do this in a real database, it would be more interesting. Then you have growing indices, and then we're not using the indices here. Here we will have a short reference regarding what exactly this is, and for people to not just imagine that you can just delete these indices without thinking. I always turned on this cluster, the tracking of it here, so they're present here according to the tables. And you can look at how many blocks were read. Yeah. Now, about function. The function here are just the internal PG profiler ones, the ones he calculated himself. They're all his function. You can see the total time, the self time. The total time is the time that was taken in order to carry out the functions, and the self time is the amount needed to read the code of the function, not taking into account the time required to carry out the functions that it caused. So this is just the search for the functions that are actually doing something within themselves. Now, functions by executions, we understand that we are searching for the functions that are most frequently executed. Now, vacuum related, we look at the ones where something interesting is taking place in terms of double taps, and maybe we need some vacuum to be going. The last of the vacuum is when the vacuum was there last time, and PGBH accounts, like you see, it never even went in there. And by modified Tapple's radio is there in order to track if we need to get an analyze on board, just in case we find ourselves with a table that has significant changes and for some reason it has not been analyzed for a while. And this is as far as the reports go. A comparative report. Now this is a fairly new phenomenon. Maybe I think a couple of months back, I can't recall exactly, but this is the very thing that allows us to have a look and to compare the current load with the loads of, I don't know, let's say 2 weeks ago, when we want to compare what and how happened. But it's not done exactly the same as it is done in Oracle, because here Oracle has some peculiarities that are not very understandable. So here I am relying on the intellect of the administrator who is going to be examining this report. But here we just have 4 functions that are naturally different between each other, only for what are we comparing against each other. Are we either comparing them according to the identifiers of the snapshots or by the baseline names, and all of their combinations. Now, the division, and it's going to contain all the information, but with 2 intervals now. And now the second test, where we just increase the timing for twice, during which PG time works. And now we're going to try and search for, now this is a simple report about this period of time. And you understand that we now have many commits. Now, where is it? 138,000, almost 139,000, and most of them are here. But it's not interesting. We've seen all this before. It's interesting to look at this. Now, the differential report. Everything is very clear. The database for the first snapshot, it's meant to be showing a hint, yes, and it shows for what is the interval that is doing and how long it took, and same for the other one. And the statistics which it has gathered, of course, maybe we need to do with the format here for it to be easily read. I'm going to think about this later, but this is exactly how it looks like, and it's identical for the rest. What was the growth here? What was the growth there? And you can evaluate this with your own 2 eyes and understand what exactly has taken place here. So the database, you have calls, you have a almost growth by 200%, and for some reason there is 2 vowels, but I'm guessing something else happened there and service-wise. So query stats, yeah, there we go, 71,261 we had, and now 30,000 and more became with accordance to this number here, respectively. They did not lie in a single instance. Now, this is the kind of thing that allows us to compare what was at some point in time and what is now when we're doing some golden baseline, where our system works well, and when something does not work well, we're just trying to compare it to the golden baseline and figure out what exactly has changed. And now, the specifics of installing it, you have the PGPL SQL extensions. We just copy the file, click Create Extension. Well, it needs the DB link if we are being very good. It doesn't require the reattestation, just because if you're only trying to just use the neighboring clusters, then you don't need any PG statements. But if you have the time, it's better to do so if you want to continue working here. Of course, it is better to place it outside in a separate schema, because it's going to just multiply the functions that are present. He's going to get a lot of tables in place, a lot of views. And in order for all of this not to be ruining the public schema, it's better to just put it on a separate one. And just for the simplicity and the comfort of summoning the functions, it's also good to alter a couple of things here and there. Now, the parameters that are impacting the statistics that are collected. Now, PGStat statements. This is an important parameter. PGStat statement max 1,000, or as much as you need, depending on the system. It strongly depends on the system. But we must not forget that this thing shares the buffers and reserves the place for storing the statistics of queries. So I don't think that it's a good idea to do too many of them. So PGStat statements track in the top call, I think it's clear that it's either collecting the top layer statistics, or it's trying to unwind it to the inbuilt calls for it. Now, be careful with them. I'm going to tell you why later. Now, PGStat save is clear. We don't really need to save them, because we're going to be saving them in our snapshots anyway. Well, not all of them, but... Now, the statistics collector track counts, it's turned on by default. The track timing here, you must be careful, because on certain platforms, the tracking of time on the input and output can significantly alter the performance you're getting. So you have this utility to retest timing, where you can somehow evaluate the effect that it has. And then PG track functions, BL, the procedural extension and the procedural function, and all of these involve the SQL, the AC, and so forth. Now, the parameters of the extension itself, the PG profile top N is how many requests, how many queries, how many tables, and the top sorted lists are we going to be collecting into our snapshots, and how many are we going to be showing in our reports. And the retention is how much storage time we have in days, and the storyline allows us to override this. Now, what about the problems? Everything, as usual, is not simple. Now, the collection of statistics at the very end of the completion of an expression, Postgres collects the statistics of the execution of statements when they are completed. So if you have a 3-week select hanging around, then we will not be able to find out anything about it. But in the last snapshot, when it's going to be completed, it's going to have the entirety of the information 43 weeks. So you may be surprised that the time of the execution of the queries is going to be longer than the interval time we have while we are actually tracking it. Now, stats statement track all is going to get all of them together in one PG stat statement, which is why you're going to get some nonsense in the total field, because this total is just the field of the time that you're getting. There are various metrics, but you end up with nonsense over there, because you get it accounting for the same things a number of times over. So we need to choose here. Either we are tracking everything with unwinding it down, or we have a more or less actual total. Then we use PG relation size in order to obtain the size of the relations, and that thing is expecting to be blocked, and if you are unlucky, you will have some DDL there or something else similar, and then that relation size is going to be stuck waiting for the blocking. There, I think there's a safeguard for 3 seconds in place, but if in 3 seconds it's waiting and it can't handle it, then it just falls off, just shuts down for the snapshot to not hang. And I'm going to think, what can we implement here? Because there are a number of things we can actually do. You can get something out of PG class. but I'm pretty sure that that's going to impact its accuracy. Now, the storage in snapshots of only the n writes, because we're only holding the top stories, it can become the reason for inaccuracies back in the tail end, because some object can have been blinking. It could be either part of the top end or not part of the tail end. So if it's jumping back and forth, we will be able to collect half of the statistics and half we will not be able to see, but this is only going to be in the leftover tails. And plus Postgres with the clouds, because it's not easy to upload the extension there. But there are various ways of getting around this. Now, for example, because PLPG SQL is there, you can just script it, and it's not going to be an extension. It's going to be hard to update, but nonetheless, it's going to be there, and it's going to be working. It doesn't really need anything else to function and to live. Now, there are also users and databases with the non-standard rights in RDS. My colleague has showed me certain magic tricks you can do with this, and I'm, of course, going to work with this. What else can we do? And because you turn out having a database which you can't connect to the super user of Postgres, which are usually given to the administrators of this cloud services. And so it turns out that the PG profile dies because it can't connect to the database because it wants to, but it can't. But these are just small things, and of course we're able to deal with this as well, but with the possibilities of installing the extension, I've already explained this. I think I'm done. Thank you very much for the attention. Maybe I can answer one or two questions here. Thank you very much. You have carried out great work, and I really like the scale at which you're working. Please, can you tell me, do you have plans to write some exporters for Prometheus in order to see this in Word and Graph in a beautiful form? Well, do you understand what exactly they want to see? What exactly from here do you want to see in Prometheus? Well, you have HTML reports that I think is very viewable on graphics. So, for example, the same parameters and the amount of queries on the top tables, for example. But to just change these parameters and to store them in Prometheus, I think you could just get them there. Well, I'm not very familiar with Prometheus, unless it's going to be a necessary feature, and maybe Prometheus will be able to hold its own when we upload it there. But the functions that build these tables are separate, and we can easily play around and get an HTML table on the side. Grafana can work with a data source, with SQL as a data source, and this report can be built in the Graphane itself. Well, Grafana knows how to work with the tables, and it knows how to enter Postgres, so we don't really need Prometheus here. Well, I'm pretty sure that what we're going to have a problem with here is that the reports are built by the identifiers of the snapshots. I think it's not comfortable to build the query like this, because who knows what identifiers are going to be, because if we get a date and a time with it, it's going to be much simpler. Thank you very much for the report, for your interesting presentation. What about the documentation on the internal parameters? Do you have it? Like what functions can be used to pull what parameter? What do you mean parameters? You have like 1, 2, 3 functions. They have fairly evident names, and so you have like the functions with the suffix of HTML. They're part of the HTML table, but without this, it just turns the table inside out, and the sorted table is at the end, which you can use. And another question: was I correct in understanding that if we are doing one server that is collecting all the reports from all the different servers, then a certain extension and something additional needs to be placed exclusively on the server, that we do not need to install anything on the subordinate servers? Well, you'll need stat statements, you'll need their stat statements, and that's it, yes, and that's it. Well, that's why it was made this way, so that you do not need anything else. The only thing here we have is that the problem with stat statements. The thing is that it's having issues with 1S, for example, or 1C, because 1C allows a huge amount of queries and it just does not get into any stat statements. So you either need to continuously be taking snapshots, but again, why would you do that? Or it just doesn't fit anywhere, and so we just have to run with the statistics of the objects themselves. And then we necessarily must have the super user rights, right? Yes. because according to the politics of the confidentiality, it's not going to show you the text of the queries unless you're the super user. So there is no way, but this is because of the PG stat statements, right? Yes, yes, mainly so, because maybe you can work around with the rest, although I haven't tried, but stat statements is very important, and usually, like, I think a lot will be lost here without it, but you can try without it, and if you'll have enough rights, well, of course it'll be very awesome if we'll have some minimal amount of rights necessary. Well, what do the authors have to do with anything? Well, it's security. Like, who is going to allow somebody unknown to go and look at the results? In order to do backups, you don't need the super user rights. When you're doing the backups, you can't get any data out of the database. Why? I mean, like with the query. You can't just get it out of the query. So, for example, you just ran the... Why do you need the query if you actually have the data? Well, if you have the opportunity to get the data out of there, well, it's a different conversation, but it's not regulated by the SQL safety policies. Well, it's very unevident why the PG statements require super user rights. Because PG stat statements can have access to any person who has access to your database, so he could, for example, select anything out of the entire base. Well, I think they have the PG modder there, and they're working, right? And I think some other rights. Well, in the modern Postgres, we start seeing the division between the rights among all these. Well, I'm unready to yet say maybe they really do have some sort of a similar thing. Because in the same Oracle, for example, you don't need the CIS, the full admin rights to write the report. I think even the common user, well, of course, yeah, in Oracle, they have plenty of users. They have sys operator and so on and so on. Can I ask a question? When they are addressing in stat statements to certain fields that appear and disappear in the various versions of Postgres, is there some... Well, how to say this? What versions of Postgres is supported by this extension? Well, it started from 9.6, and then we had some changes in the 10th one. Some functions that include the touch on the val, they shifted somewhat in the 10th, so they are dropping the support of the old one. No, why? They're just looking at what version of the clusters are there. So yeah, they have the check of the versions. But yeah, you have the min participation there, which was not there in the 9th. Yeah, the point is, if you find where it works, just write to GitHub, and we're just going to figure out where it's not working. Thank you very much for this great development and the reports. And I want to ask a question, which probably does not have an answer, but would we have an opportunity to look at the planned queries, or to at least trace the fact that the plans of a certain query has changed? As soon as we'll be able to get this out of Postgres, I will be able to insert this. So far, this does not exist in Postgres. We don't have the opportunity to look at the plans of the sessions of other people. I heard that in the reports you can look at only the completed queries, but it is interesting, why can't you look at the deadlocks? Because this is not a deadlock tool. The deadlock is what reports have been sent. No, deadlocks are not shown in the actual Postgres. They're shown in logs, but we don't analyze logs with this because this would require some additional rights to the file systems where we're going to be reading these logs from, some additional settings, and so deadlocks are only placed in logs, and you can't really see them. So as far as Postgres can understand, if they would be present, then it would be interesting. Hello, thank you very much for the permission, for the extension. This extension is very needed, and I have the question: how does this react to the statistics reset? It's a good question. This is the correct question, because if you have reset certain statistics by hand, then what is going to change from the last snapshot to the change in statistics is going to be lost, and it's not going to be part of the snapshot, and you're going to see less values in the next snapshot. But this is only going to be true until the next snapshot, and everything is going to go back to normal. And so I have the question: so to maintain the delta with regards to the previous snapshot, now do we have an opportunity to have the absolute values at the moment, for the moment of the snapshot? Well, I had the thoughts Why do I need to keep the deltas here? Because I have the snapshots, and I can just put the absolute values inside the snapshots. And so when I will need to get the report together, I'll not need to sum up all the deltas. I will not need to just subtract the first one from the last one. But that doesn't work, because you may have new tables that would have appeared and would have disappeared, and at the moment of the first snapshot they would not be there, and then at the second snapshot they're also not there, and so everything what happened to them while they were present before they disappeared and after they were created, you don't understand what has been going on. So you have the delta there, and to keep the additional values in it, in addition to this, well, I don't see the point. Yeah, you have absolute values, sure, but they're not going to give you anything because they're going to be there from the very beginning, from the long time ago. But okay, so use case, the amount of scans of indices. Yes, but you want to know it for some period of time, not since the very start. Yes, I think I understand. Yes, thank you. What approximate load does this generate? Does this extension generate on the machine that we're monitoring at the point when we are collecting the data? And what load is this load on the host node where it's actually running in the case when these two are separate? Well, on the host node you don't get too much of a load. The most feelable load is on the base that it monitors, but this heavily depends on, well, from the beginning on what's that statement's size you have, so how many queries is there, and then it really depends on the amount of relations you have in the database. So for example, in the case of 1C, this can take 10 seconds. Well, okay, let's say 10,000 relations. How long is that going to take? Well, once again, this depends on the power you have, but I think a minute, yeah, I think a minute will be done. Well, because it's done rarely, and Oracle does this only once in an hour, so you can just pick an interval and do it over that time period. And it will just take it for the time you indicated, and then it's not going to continue loading this up. And once again, this is all done in a single flow. If you have many cores, then you will not even notice this. Was I correct in understanding that the configuration of the timing when it does the snapshot, so the moments when the snapshots are taken, is uniform for all the host carrier and the entire extension? Well, look, if you really need to collect the information on some nodes in different times, then you can just disable them and you just get a couple of schedulers that are going to be calling forth the nodes that you need to look at with a different policy of snapshots. This is how it is for now, because we ourselves do not control these processes of launching. This is done by cron now. So if we spread the load, then we need to disable everything and to do everything manually. Yes, you can do it like that. Thank you. And then I guess we'll call it a day, because our time is almost up. Yep, that's it. Thank you.